Welcome to Learning to Engineer. If we have a unity feedback system, we can find the steady state error by this method. In case you do not have a unity feedback, there is a feedback transfer function given. What will you do in this case? How will you find out the steady state error? You cannot apply the formula that is there in this table. You need to think about the error term and then find out the error coefficient. Then you have to find out the steady state error ESS. We are going to look at that in this videos. There are actually two ways to do that. Both are really simple ways and you can choose which one you want to do. Let's get started. In the previous video, we found out the steady state error considering that the h of s is 1 or this is a unity feedback system. So considering that, we derived the values of the steady state error for step, for ramp and for parabolic input. Then we formulated a table like this. This table can be applied only in the case of unity feedback systems. In case of non-unity feedback, you need to calculate the error and then find out the error at steady state. At steady state means at t tends to infinity, what is the error? This is called as steady state error. In other words, when you convert this time domain system into a Laplacian domain, t tends to infinity will become s tends to 0 and that the error term will be e of s multiplied by s. Okay, so this is the steady state error for a given system. We have to find out the E of s separately and then find out the steady state error ESS. We are going to do that in this video. Consider this non-unity feedback system. Here we have the open loop transfer function g of s as 1 and h of s is this. Okay, so in this case, what is the error term? We can find out the steady state error. Okay, so what is the E of s? E of s is equal to R of s minus H of s into C of s. What is the C of s? It is the error term which is coming out of here multiplied by the G of s. Okay, so since C of s is equal to G of s times the error, we can substitute this in this equation. We saw all of these in the previous video, so that's the reason I'm just skipping the steps and directly writing this. So E of s into 1 plus G of s into H of s will be the value of R of s. What is E of s? It is the input R of s in Laplacian domain divided by 1 plus G of s into H of s. Okay, so what is steady state error? The steady state error is equal to limit as s tends to 0 s into E of s. Okay, so this is actually E of s is actually the steady state at time t tends to infinity, the value of E of t. This is steady state error. By final value theorem, we can convert the time domain into the s domain because at final value at t tends to infinity, s tends to 0, s into E of s. Okay. This is the value of steady state error for any system, be it unity feedback, non-unity feedback, any kind of a system. This is the value of the steady state error. Okay, so we are going to just substitute this value into E of s. So what is the steady state error? It is limit as s tends to 0, s into this term, which is R of s minus 1 plus G of s H of s. So enough of all stories. Okay, so I am very sure you would have understood all of these in the previous video. So here on I am going to solve this question. What is the steady state error of this transfer function? The actual question is, for the steady state error to be 0.01, what should be the value of the gain k? This is the question. Okay, so for this system transfer function, what should be the value of k so that the steady state error is 0.01? The value of E of s is equal to, this is a unit step input, so R of s is 1 by s, R of s divided by 1 plus G of s into H of s. So it is k divided by 10s plus 1. We can simply simplify and we can get 1 by s is equal to 10s plus 1 plus k divided by 10s plus 1. Okay, so what is E of s? 10s plus 1 divided by s into 10s plus 1 plus k. Okay, so this is the value of E of s. The steady state error ESS is equal to, limit as h tends to 0, s multiplied by 10s plus 1 divided by s into 10s plus 1 plus k. So these terms cancel, and as s tends to 0, what is the value of steady state error? This is equal to 1 divided by 1 plus k. And it's given that the steady state error should be 0.01. So what is the value of k? We can just simply cross multiply and find out. Point not 1 can be written as 1 by 100. So this implies that 1 plus k is equal to 100. Correct? So what is the value of k? The value of k is equal to 99. There is also another way to solve this problem. Whenever you have a non-unity feedback system, you can convert that into a unity feedback system and then find out the steady state error. That's also a easier method, and provided you are thorough about the block diagram reduction technique. So consider you have an open loop transfer function g of s, and this is a, let's say, negative feedback system. So you have a h of s, feedback term is subtracted from r of s. Okay, so this is a negative feedback system, let us say. So in order to make a unity feedback system, you need to be converting this into a format like this. So this is how you have to convert a non-unity feedback into a unity feedback, and then you can apply the static error coefficient formulas. How do you find out g dash of s? So to this point you want a unity feedback, so the feedback term should be plus 1, correct? So when you are adding another loop, you have to subtract the same quantity so that the effects get nullified and you are not changing the original problem statement. Okay, so we can also subtract a term which is called minus 1 from the C of s, so that this term and this terms cancel each other. Okay, so after that what are we going to do? We will evaluate the transfer function of the whole system. Okay, so the transfer function of this system is going to be g dash of s, and it is this. Okay, so to this g dash of s we have a unity feedback. So when we find out g dash of s and use that as an open loop transfer function, we can then find out the static error coefficients just by the formulas given in the table. Okay, we are going to do that method as well. Okay, so in this problem, what is g of s? G of s is given as 1 and h of s is equal to k divided by 10s plus 1. So what is the transfer function which is c of s by r of s? Okay, so the natural transfer function of this system would be g of s, which is 1, divided by 1 plus g of s into h of s. which is the basic formula. Okay, let us simplify this. We will be getting 10s plus 1 on the numerator, and in the denominator it will be 10s plus 1 plus k. Okay, so this is the modified transfer function. So we have a setup like this now. It is an intermediate setup. Okay, to this we added a minus 1 and then we added a plus 1 term. Now let's evaluate this red color box. Okay, so we have the h of s, or let's say h dash of s, as minus 1, and this is the let's call this as GA of s. Okay, so the transfer function of the whole box is g dash of s, which we are going to find out. G of s divided by 1 plus g of s into h of s, which is the normal formula. So it is 10s plus 1 divided by 10s plus 1 plus k whole divided by 1 plus g of s into h of s, which is minus 1. So the value of g dash of s will be 10s plus 1 divided by 10s plus 1 plus k minus 10s minus 1. So this 10s cancels and the plus 1 minus 1 cancels. So what is the value of g dash of s? This is 10s plus 1 divided by k. So now this is the transfer function of, this is the modified open loop transfer function of the system, and to this we have a unity feedback that's connected. So in this case we can right away apply the formulas, because this g dash of s, okay, is a unity feedback system. So steady state error, since it is a type 0 system, okay, how to find out the type of the system? You can watch this video and find out the type of the system. So what is the steady state error in this case? This will be A divided by 1 plus Kp, where A is the DC gain and what is Kp? This is positional error coefficient Kp. So what is the DC gain? The gain of the open loop system when S tends to 0. Okay, so when S tends to 0, the value of g dash of s is going to be 1 divided by k. So 1 by k is the DC gain. So what is the positional error coefficient in this case? This is equal to Kp is limit s tends to 0 g of s multiplied by h of s, since this is a type 0 system. Okay, so what is a type 0 system? Check out this video. Okay, so this is a type 0 system. So what is the value of Kp? It is limit s tends to 0, 10s plus 1 divided by k, which is g of s, and what is h of s? It is 1. So the value of Kp is 1 by k as well. So the steady state error of this case will be A divided by 1 plus Kp. So this is equal to A is also 1 by k and Kp is also 1 by k. So what's the value of the steady state error? It is 1 divided by k plus 1. And it's given that the steady state error is 0.01. So this implies that 0.1 is 1 by 100, correct? So this again implies that k plus 1 is 100. And what is the value of k? K is 99. So in both these methods, the value of k is 99. The second method as well as in the first method. Okay, so in both cases the value of k is 99. Okay, so we have now seen how to find out the steady state error of a non-unity feedback system. You can choose among these two methods. You can understand each one of them and see whichever is easy for you. You can go ahead with that. Thanks for watching. Let me know your thoughts in the comment section, and if you like this video, do hit the thumbs up and also refer this channel to your friends who are trying to learn electric concepts. Thank you.